Now, in the last lesson, we saw how we could use if, elif, else to check for multiple conditions. But in this case, we're only checking one condition, even though we have multiple. Because if this first condition is true, then we would do whatever it is we need to do, and then we would bypass everything else. Now, what if you're in a situation where you need to check for multiple conditions, even if the previous one was already true? Coming back to our roller coaster ticketing problem, if you're going on a good roller coaster ride, you'd probably want to keep a picture for the memories, right? And our roller coaster is no exception. We want to be able to charge users an extra $3 if they want to purchase a ticket that includes a photo. Now, this is quite interesting because this is completely independent of their age or their height. Even if we've already gotten their age and height and determined their ticket price, this is an extra question. Do you want a photo or not? Yes or no? If you do, then we're going to add $3 to your existing ticket price. To do this, we would write multiple if conditions. If condition 1 is true, then do A, but then the code is going to go to the next case and check if condition 2 is also true, in which case it will do B, and if the final condition is also true, it's going to do C. Whereas on the example on the left here, only one of these things, A, B, or C, will be carried out. Comparing the example on the left, where we're using if, elif, else, only one of these things, A, B, or C, will be carried out. But on the right-hand side, all three conditions are checked. And if it so happens that all three conditions are true, then A, B, and C will all be executed. Currently, our code operates like this. We check for their height. If they're over 120 centimeters, we check their age. And depending on their age, we give them a different price ticket. What we now want is, even after we've checked for their ticket price, we want to ask them a question. Do you want photos with your ticket? And if the answer is yes, then we're going to add $3 to their bill, no matter which type of ticket they've got. And finally, we give them the total bill. If they say no, then we jump straight to the total bill and just tell them the price of their ticket. So how do we implement this in our code? Well, first, let's change these print statements. Instead of giving them the bill at each of these steps, I'm going to tell them which type of ticket they're eligible for. So the next thing to do is to ask them whether if they want a photo or not. So I'm going to need to use an input. But the question is, where do I put that? Now, the correct answer is that it has to be at the same indentation level as this if block. So you can imagine this whole thing with the if, elif, and else as sort of belonging together, because they all relate to one thing. What is their age and which type of ticket are they eligible for? Now, outside of that if statement, I'm going to create an input and ask the user, do you want a photo taken? Type Y for yes or N for no. And then I'm going to save their input inside a variable called wants photo. So now I'm going to use an if statement to check what their answer was. If it was true, then I'm going to add $3, and if it was false, I'm just going to skip to giving them their ticket price. So here is where I write my if statement. Notice how it's at the same indentation level as this previous set of if statements, but it's not at the same indentation level as this set of if statement. So essentially what's happening is, once I've checked their age, then I'm going to check whether if they want a photo or not. And this is going to apply to everybody, no matter their age. So if wants photo is equal to Y, well, in this case, I'm going to go and add $3 to their bill. But how can I add $3 to the bill when I don't have a variable to vary? So instead of using these print statements, I'm going to create a variable up here called bill, and I'm going to set it to equal 0. Now, in addition to printing to the user how much their ticket is, I'm going to set the bill to the price that they're supposed to pay. So if age is less than 12, bill is equal to 5. If age is less than 18, then bill is equal to 7. And finally, for everybody else, the bill is equal to 12. So now, depending on these conditions, the variable bill is going to be changed to a different number. But once we land in this if statement, I'm going to have to add $3 to their bill, no matter which value it is at the moment. So effectively, what I want to do is bill equals the current value of bill plus 3. So if bill was 7, then this new value of bill should be 10. If bill was 12, then it should now be 15. Now in Python, as well as many other languages, there's actually a slightly shorter way of writing this. When you want to increase the current value that's held in a variable and you want to save it back into the variable, you can simply write plus equals. So bill plus equals 3 is the same as bill equals bill plus 3. Now, no matter what the value of bill is before it reached this if statement, I'm still going to add $3 to it. Now, after this if statement is completed, I don't actually have to write a companion else statement, because in this case, if the answer is no, then we're simply going to do nothing. We're not going to do anything to the bill. Instead, I'm just going to skip ahead and print to the user their final bill. And I'm going to use fstrings to insert the value that the bill variable has into this print statement. Now, for your code to work, the indentation matters a huge deal, because the computer will think you want it to do different things depending on the indentation. So notice how this indentation shows that this bill plus 3 is to be executed when this condition is true. But this print statement is not indented to the same level, and effectively it's going to happen after this if statement has been executed. So you can play around with indenting this print statement, unindenting it, and see what the difference is. But now I'm going to go ahead and hit Command Enter or Control Enter on Windows to run my code. And I'm going to go ahead and try and get a ticket. So let's say that I am 21 years old. It tells me that adult tickets are $12. And then it asks me, do you want a photo taken? So yeah, I would love to have a photo taken. And it tells me that my final bill is 15. So I forgot a $sign here, but effectively it's now added the $3 to the $12 because of this additional if statement. So if this concept is still a little bit confusing to you, then I want you to really study this flowchart and just look at the difference and visualize it, because the if, elif, else statement is only ever going to be true in one of these arrows, right? You can't be less than 12 and 18 and over. And similarly, it doesn't make sense for you to have two different ticket prices. But with the want photos, this condition has to be asked no matter whichever branch they landed on. So it's completely separate from this if statement. And once you've had a look at this flowchart, then compare it against the code, and the way that the code works should be a lot more obvious. And once you're happy with the code and this concept, then I want you to head over to the next lesson where I've got a code challenge for you. So for all of that and more, I'll see you there. All right, guys, are you ready for another challenge? In this challenge, you're going to be building a pizza order program. So we're going to ask the user what size pizza they want, small, medium, or large, whether if they want to add pepperoni to it, and whether if they want extra cheese. So based on the user's input for each of these variables, and the input's going to come in the form of a single capital letter S, M, or L, Y, or N. Based on that input, we're going to try and figure out what their final bill is going to come to. And you can take a look at the prices over here. So if you want to add pepperoni for a small pizza, it's $2, medium or large pizza is $3, and extra cheese is $1 for any size. So you're going to use what you've learned about multiple if statements, as well as everything from previously, in order to be able to create this, so that if the user types in, for example, this inputs large pepperoni with no extra cheese, then it should print out your final bill is $28. So have a look at the examples and the hints and go ahead and solve this coding challenge. All right, so this one shouldn't be too hard. And we're going to start off by creating our first if statement, where we're going to check what is the size of the pizza that they chose, so we can assign the price to that pizza. If the size is equal to S, that means they ordered a small pizza. Well, in this case, the price should be $15, right? Now, we're going to create a variable up here before the if statement so that we can keep track of the bill. So size S, the bill is going to be increased by $15. Now, you can, of course, simply just set the bill to $15 in this case, but because we've got a lot of things that can change the bill, it's easier to simply just add 15 to what it is currently, using the plus equal sign that you learned about. Then we're going to check with an elif the size is equal to M. So if they chose a medium pizza instead, then the bill is going to increase by $20 instead. And finally, for all other cases, namely if they got a large size pizza, then we're going to increase the bill by $25. Now, notice how here you could have also used an elif and said elif size is equal to L. Well, in that case, the bill increases by 25. And you don't actually need an else statement. It's not required. If you feel like it's easier to read like this, small, medium, large, and what should happen for each case, then you can just leave it like this. But of course, there is an argument to be made that the user might have typed something wrong, right? They might have typed a lowercase letter, they might have typed a completely different letter. So in future lessons, we're going to show you how you can catch these cases and how you can deal with it. But for now, let's just keep our program simple as possible. If they type the wrong letter instead of S, M, or L, then we're just going to overcharge them. So now that we've established what the basic price for their pizza is, we're going to look through the add-ons. We're going to see if they said they wanted to add pepperoni. So if add pepperoni is equal to Y, well, in that case, we're going to need to check if they have a small pizza or a medium and large pizza, because the price is different. So we're going to have a nested if function in here. We're going to say if add pepperoni is equal to Y, and then if the size is equal to S, well, in this case, we're only going to add $2 to the bill. But if the size was any other size, basically medium or large, so we can catch that using just an else statement instead of creating 3 separate if sizes S, if sizes M, etc. And in this case, we're going to add $3 to the bill. So now we've got this case covered. The final thing is whether if they said they wanted extra cheese or not. So if they did, in fact, want extra cheese, well, in that case, all we have to do is just add $1 to the bill. So these are 3 separate sets of if statements. This one, and this one. And by the end of all of these if statements, as long as we're at the right indentation level, namely right next to the gutter here, then we can go ahead and calculate their bill and print it out for them. So we can say print, and I'm going to use an F string to insert the bill in here. Print your final bill is, and then I'm going to add a $sign, and then inside the curly braces, I'm going to put in the current value of the bill. after all of these calculations. So did you manage to get it right? Did you manage to use a combination of if statements and elif statements, nested if statements, or did you do it in a different way? And it's totally cool if you did. As long as it does what it's supposed to do, then it doesn't really matter whichever format of your code you decided to go for. And as a matter of fact, there's loads of ways that you could have written this code to get this functionality. Some of them will be slightly more readable, some of them will be slightly less readable. So it's a case of you making a good judgment on that and choosing the code that makes the most sense to you. Now, in the next lesson, I want to talk a little bit about combining different conditions so that we can use something called a logical operator to check for multiple conditions in the same line of code. So for all of that and more, I'll see you on the next lesson. Now, up to this point, you've seen us use if statements, else statements, elif statements, multiple if statements, as well as nested if statements. But the thing that we haven't been able to do thus far is to check for multiple conditions in the same line of code. So how would we be able to combine different conditions and say, well, is the pizza large and the user wants pepperoni and extra cheese all in the same line of code? Well, to do this, we would need to learn about the logical operators. So there's 3 of them that are really useful: and, or, and not. So let's take a look at the first one. When you combine 2 different conditions using an and operator, they both have to be true, both A and B, for the entire line of code to be true. If just one of them is true, say A is true and B is false, or A is false and B is true, then the overall thing evaluates to false. So if we take a look just inside the console, and in fact, I'm going to clear the console, and I write some code here. Let's say that A equals 12, right? Now, let's say that I wanted to check whether if is A greater than 15? Well, that is going to be false. Now, what about is A greater than 10? Well, that's going to be true. Now, if I combined this using an and statement, I could say, well, is A greater than 10 and A is less than 13 and hit enter, then I would get true, because both A is greater than 10 and A is less than 13 are true. So in this case, when both conditions are true, then this entire line gets evaluated to true. But see what happens when just one of them is false. So is A greater than 15 and A less than 13? A is greater than 15 is false, A is less than 13 is true, and now we get false. So that's what happens when you combine different conditions using and. Now, if you only needed one of the conditions to be true, then you could use the or operator instead. So if C or D were true, or if they're both true, then it will evaluate to true. It's only when both C and D are false does this statement actually become false. Now, the final one is the not operator. And all that this does is it basically reverses a condition. So if the condition is false, then it becomes true. If it's true, then it becomes false. If I wrote not, and then I wrote the condition, A is greater than 15, A greater than 15 is definitely false. 12 is less than 15. But by putting the not there, it's going to reverse this, so going from false to true. So when I hit enter, you'll see it is now true. Coming back to our roller coaster ticketing, let's say that the roller coaster company decided that for everybody who is having a midlife crisis, they would give them free tickets. And according to Wikipedia, midlife crises typically occur when you're 45 to 55 years old. Let's see if we can incorporate this into our code. So let's say that in addition to these existing price categories, what if you had to add a separate price category for those people who are aged between 45 and 55. And those people get to ride for free. Do you think you would be able to change the code using what you've learned about logical operators in order to incorporate this addition to our program? Pause the video and give that a go. So we've currently got 3 conditions: age less than 12, age between 12 and 18, and finally everybody else. Now, instead of just finishing up there, let's go ahead and add another elif. And here we're going to combine 2 conditions. We're going to say if the age is greater than or equal to 45 and the age is less than or equal to 55, then we get to catch that midlife crisis window. Well, in this case, we're going to print something like, we're going to say everything's going to be okay, have a free ride on us. And in fact, we don't need to modify the bill in any way because we know that with if, elif, and else statements is that once this condition matches, then everything that's inside this block, so everything that's indented inside this elif, is going to be carried out, namely printing this out, and then it's going to skip the rest of this if-else block and continue on. Now, if they want a photo, they still have to pay $3, but at least their ticket is free. And we've been able to do this because we know about the AND logical operator. In the next lesson, we're going to practice using logical operators some more by completing another code challenge. So for all of that and more, I'll see you there. All right, guys, it's time to show what you're made of. Here's another code challenge. And this one is, again, another difficult challenge. And the arms really show you just how difficult it is. But you're going to flex and you're going to get stronger. And it's only through struggle that you're going to become a better coder. So in this code exercise, we're going to build a love calculator. And the way that it's going to work is the same method that I used when I was 10, pretty much. And I really recommend reading up on this particular BuzzFeed article, which is, of course, very reputable, and it's going to tell you exactly how this program is going to work. So once you've managed to scroll past all the GIFs, it will tell you the method. So you write your name, his or her name, and then the words true and love. Now then, you're going to count the number of times TRUE occur in both of your names, and then you're going to count the number of times LOVE occur in both of your names. Once you've got those numbers, so here TRUE adds up to 6, LOVE adds up to 3, then you'll get the percentage that you are compatible with this other person. So not only do you get to learn programming on this course, you also get to discover your destiny. The idea is that we're going to convert this very time-consuming process into a computer program. So once you've understood how it works, you're going to write the code for it. Now, in order to be able to calculate the love score, there's 2 important things that you should read in the hint. One is you will need to use the lower function. And all that this does is it takes a string, let's say we've got the string Angela, and notice how that first letter is a capital A. If I write dot lower parentheses, then it will reduce all of the capital letters to lowercase letters. And if you were wondering how you would have known to use this, then you can head over to this Stack Overflow question in which somebody asks exactly this question: how do you turn something that's uppercase into a lowercase character in Python? The second function you'll need is the count function. And this will give you the number of times a letter occurs in a string, which is super useful when it comes to this particular challenge. So again, let's use our string Angela, and then I'm going to write count, and then in between the parentheses, I'm going to specify what it is that I want to count. So let's say I want to count the character A inside this string, and I hit enter, it comes up with 1. Even though you can see there's actually 2 A's in this string, in my name, it only counts 1 lowercase a. So that's why this first step was super, super useful. So let's say lowercase name equals Angela dot lower. And then let's go ahead and do lowercase name dot count. And then we're going to count for A again. Now you'll see it gives us 2 because we were able to convert everything to lowercase and then use the count function to check the number of times the character A occurs in this string. And again, I've linked to a Stack Overflow question, which is how you might have found out to use this count function and how you might use it in terms of code examples. Now, there's a second step to this challenge because not only do we want to know the love score, we also want to give the user an interpretation. So the interpretation is here. For love scores that are less than 10 or greater than 90, the message is going to say your score is X, and of course replace that X with the actual score. You go together like Coke and Mentos. Now, if their love score was between 40 and 50, the message is going to read, your score is whatever it may be. You are all right together. And finally, for all other scores, the message is just going to give them their score. Your score is XYZ. In this case, there's 2 inputs, somebody's name and then somebody else's name. And then you're going to check for the number of times TRUE occurs in both of those names, LOVE occurs in those names. Then you're going to combine these digits together to get the love score. Pause the video now, have a look at everything that's in the instructions, read it all, and then go ahead and give that a go. All right, so the first step is to work out the love score, right? So we need to figure out how many times each of these letters occur in these names. The first thing that we need to do is to combine the names because we're looking for the number of times, let's say T occurs in these names, and we're treating them as one string, right? So I don't want to check it separately and then have to add it together. So let's call it a combined string, and let's set that to equal name1 plus name2. And this is just going to concatenate those 2 strings together. So we'll be able to check them only once. Makes it more efficient, right? The next step is to guard against cases where the user is inputting their name like this, which many people do, or they might even write it like this. So we have to turn everything into lowercase. So let's call it lowercase string. And that will be combined string dot lower, just as I demoed previously using this lower function. So now we've got everything in lowercase, we're going to start checking for this first word, TRUE. So let's first check how many times the letter T occurs in this lowercase string of both people's names. So we can say lowercase string dot count, and then inside the parentheses, we specify the string we're looking for, which is T. And then I'm going to save this to a variable, which I'll just call T again. And then we're going to repeat this several times. Hopefully, for practice sake, you'll type it all out. But in my case, I'm just going to copy and paste it, which is usually error prone, but we'll try to be careful. So now that we've got the number of times T occurs, R occurs, U, and E occurs, we can now add it all up. So let's say true equals T plus R plus U plus E. So now we've got the first digit of our love score. And we have to go ahead and do the same thing for LOVE. So again, for time's sake, I'm just going to copy that and then go ahead and change this to LOVE and LOVE. And then I'm going to go ahead and calculate the total for that, which is going to be L plus O plus V plus E. And now I've got both of these numbers, and I'm going to try and concatenate them together to achieve this 2-digit number. To do that, I'm going to create a love score variable that's going to keep hold of this. And then I'm going to say true plus love. And remember that at this stage, both true and love are actually integers. That's how we were able to add them together. So if I want to turn them into a string in order to be able to concatenate them together, I have to convert them to strings. The final thing we have to do is just to go ahead and print this love score. So we're not going to print anything else for now. Let's just go ahead and test it out. So let's run our code and let's type my name and then their name, Jack Bauer, of course, and then it gives us the score. So 5-3. So that means everything so far has pretty much worked. So now all we have to do is use our knowledge of if statements to give a corresponding interpretation or a message. If the score is less than 10 or greater than 90, so if love score is less than 10 or love score is greater than 90, so we're using that logical OR operator here to check if either this condition or this condition is true. And if you find it helpful, which I usually do, it's easier to wrap these conditions in their own set of parentheses. Now, Python doesn't actually care. Either method works, but for us humans, this is a little bit more readable. So under this condition, what we're going to print out is your love score is, and then we'll insert the love score variable here. And we're going to, of course, be using f-string, so let's add that. And then we're going to write, you go together like Coke and Mentos. So that's our first condition done. Now, the next condition is, what if their love score is between 40 and 50? So let's go ahead and add an elif here. Elif, the love score, is greater than or equal to 40, and the love score is less than or equal to 50. So that catches the cases where the love score is between 40 and 50. So both of these conditions must be true for this statement to fire. And in this case, what we want to do is we want to print out this sentence. So your score is, let's just insert the love score in here. Your score is this particular love score. You are all right together. Now, the final thing we said is, if it doesn't match any of these conditions, then the message is just going to be their score. So that means we can catch everything else using an else statement, and we can simply just print your score is this particular number. Now, at this stage, you might think you're done, but if you actually run it, you're going to get an error. So let's go ahead and test it with the same names as before. You can see that we get a type error on line 27, and it says that the comparison less than is not supported between instances of string and int. So the problem here is that in order to concatenate these two numbers, we had to turn them into strings. So that, let's say that this number was equal to 5 and this number was equal to 6, then instead of getting 11, which is not what we want, we actually get 56 because they're both strings, and these strings get concatenated together. But the problem occurs on the next step. Because we want to compare the love score against an actual number, then if it's a string, it's not going to work. So in order to solve this, then we actually have to convert the love score into an integer. So you could use a separate step. So the integer score equals int, and then we wrap it around the love score. Alternatively, and a lot easier, is to simply just wrap that whole line inside a set of brackets and convert the whole thing into an integer on the same line. It depends on how comfortable you are with this code as to which option you'll choose. Now that we're done here, let's go ahead and run our code again, and let's just check it. Your score is 42, you are all right together. So now our code seems to be working, and we've now completed this code challenge. How did you get on with this challenge? Did you manage to get everything right? Did you get stuck at certain places? Have a think about which parts of this challenge were the hardest, and see if you can review some of those concepts so that the next time you encounter them, you'll be able to tackle them with confidence. Hey, you've reached the final project. And as you've seen at the beginning of today's lessons, I showed you what we're going to be making, which is a sort of choose your own adventure game. I don't know if you've ever read those choose your own adventure books where you flip to a different page if you make a particular choice, and then the story kind of evolves as you make your choices. Now, we're going to make a very simple version of that using what we've learned about conditionals, if, else, elif statements, as well as everything we've done previously. So you've already seen what the final outcome should look like, and if you want to review it again, just head over to treasure-island-end.appbury.repl.run, and here you'll see essentially the game in action. So it starts off asking you, you're at a crossroad, do you want to go left or right? And then you have to type your choice. If you selected left, then it's going to take you to a lake, and it asks you whether if you want to wait for a boat or swim across. So let's go ahead and wait for a boat. And then the final step is it asks you, which door would you like to go through, red, yellow, or blue? Now, depending on your choice, you'll either end up with game over or you'll end up with winning the game. So the basic setup for this game looks something like this, and I've included a link to this flowchart in the starting REPL. So repl.it/appbury/treasure island start, and of course you'll find all the links in the course resources as always, but if you scroll down there's a link right here that takes you to this flowchart. Now the first question you're going to ask the user is to make a choice between left and right. Now you can use my wording if you want. You're at a crossroad, where do you want to go? Type left or type right, but I think the fun part of this challenge is really creating your own story, right? But somehow get them to choose between left and right. If they choose right, or any other condition for that matter, tell them that they've lost, game over, for some sort of reason. In my case, if they had chosen right, the reason is because they fell into a hole, game over. But I think you're far more imaginative than I am, so go ahead and use all of those skills and make your game really fun. Now, if they've chosen left on the other hand, then we're going to take them to another question that asks them whether if they want to swim or whether if they want to wait for a boat. And if they swam, then it's going to be some form of game over. There's crocodiles, there's whatever it may be, but they can't continue. But if they chose wait, then we take them to the third and final question, which asks them to choose between 3 doors. And if they choose any door other than the yellow door, then they would lose, but if they chose the yellow door, then they somehow win. Now, notice how each of these just says game over, left or right, but the idea is really to use your creativity and make this game really your own. Now, one thing to remember though is that when the user types in a answer, let's say left or right, they might type it like this with an uppercase R, or they might type it like this, all lowercase. Have a think about how you might make sure that no matter which version they typed, you're still going to be able to catch their command, essentially. So have a think about what you've learned in the previous lessons and take a look at this flowchart. Then head over to the starting project and you can get started writing your code. Now, if you head over here and what you see is sort of like a mumbo jumbo bunch of characters, then the reason is probably because there's not enough space for this ASCII art of a treasure chest to display. So you can either do as I did, reduce the size of the console, or alternatively, and probably easier, is to change the layout to stacked, make it go at the bottom, collapse this left-hand pane, and then you've got as much space as you have to work with. Now, ASCII art is really cool because it basically just uses a bunch of characters that you know and love, like the comma and the equal sign and all of these things that together make up a picture. And you can find your own ASCII art if you just go to ascii.co.uk/art, and you'll see a whole bunch of different topics, and they've grouped a lot of things together into individual pages. So if you wanted a rhino ASCII art, then you can find a whole bunch of rhinos that people have drawn. But the easiest way is, of course, using Command F if you're on a Mac, or Control F if you're on a Windows machine, and then just search for the thing that you want. So, for example, I went and searched for treasure, and down here I found this brilliant treasure box ASCII art, which is what I'm using to print inside this print statement. Now, notice how there's 3 single quotes that are at the start, and there's 3 single quotes at the end. Basically, what the single quotes allow you to do is to create multiple lines of a string, essentially. So notice how if I go ahead and delete all of these single quotes, and I only had a set of double quotes, then it actually doesn't quite work. It gets quite confused because it thinks that this is where the line ends, but in fact I wanted to print all of this out. So to do that, instead of using a double quote, I use 3 single quotes, and at the very bottom I tell it, well, this is the end of my multi-block string, by using 3 single quotes as well. So have a go at running that, and you should be able to see that in your console you get this little Treasure Island ASCII art being printed along with the 2 sentences that begin the game. So have a look at the flowchart, have a play around with the ASCII art, and also have a look at the final version of the app so that you can go ahead and create your own version to complete this challenge. Pause the video now and give that a go. All right, so let's see if we can replicate the functionality or the logic that's shown in this diagram into our Treasure Island game. So the first thing it has to do is we have to ask the user whether if they want to turn left or right. And after we ask the user this question, we're going to want to capture their input, right? So let's go ahead and create an input function and ask our question. Now, notice how when I use my double quotes around my string, the double quotes that are inside the double quotes are interpreted as code, because it actually thinks that this is the end of the first string, this is the second string, and this is the final string. This is how the computer is going to see it. Now, previously you saw that we could do the trick where we change this to single quotes instead. But if, like me, you have this case where you have the your with the apostrophe, then it's going to think that this is actually the end of the first string, this is the second string, and this is the third string. So this doesn't actually really help us. Now, what we can do when we want to tell our computer that what I'm writing is actually not code, just see it as text, you can get it to ignore a symbol afterwards by using the backslash. So this way, it basically escapes this string and it will see it as text. And now we have a complete string like this, and this is just going to be interpreted as text because we told it to with the backslash. Now, of course, there's other ways that you could have gone around this. You could have just simply said you are at a crossroad rather than using the apostrophe. But more often than not, you'll need to use a symbol that you'll need to escape, and you can do that with the backslash. So that's just a quick tip. Now, at this point, the user is going to type a message, left or right. So let's go ahead and save that to a variable. Let's call it choice1 equals their input. Now, remember how I said they could be typing the answer as right, or as right. So how can we make sure that when we're doing our checks using the if statement, we ignore the casing? Well, one way of doing this is we can simply use the lower function to change their input. No matter how they wrote it, right, or right, it should all be converted into lowercase to this version. That way, we have one thing that we can consistently check for in our if statement, which is coming up next. So we can say if choice 1 is equal to, remember the double equals is checking whether if left-hand side and right-hand side is equal, and the single equal sign is assigning the right-hand side to this particular variable name. Now, if choice 1 equals the string right, then it's pretty much game over for our player. So let's go ahead and add our colon and print something like game over. Of course, we can elaborate this a little bit more as to why was it game over? Well, because you fell into a hole. This is like the E.T. game from the 80s. Lots of holes. So you fell into a hole, game over. But what if they had chosen left instead? Well, that takes them on to the next question. So that's the option that will allow them to continue along the game. Now, in this case, we could use an else statement and say, well, if they didn't choose right, then they probably chose left, right? But they could have also chosen like a option that was completely not listed. They could have just written something like this, and it would still trigger the else statement. So what we should actually do is to switch it around. So namely, we should say if choice 1 is equal to left, well, in that case, then they continue in the game. But otherwise, namely, if they chose right or anything else for that matter, then it's pretty much game over. So this format makes a lot more sense if you want to continue along the left side of the branch this way. Now, another thing that you might have realized because we learnt about combining different conditions is instead of using the dot lower to change the input to lowercase, you could have also said if choice is equal to left or if choice 1 is equal to left, spelled like this. That will both work. But I think in terms of succinctness and less code writing, I think this makes a lot more sense to me. So I'm going to continue with this version, but if you did it the other way, that's perfectly valid as well. Now, if their choice 1 was left, then they get taken to the next question. Do you want to swim or do you want to wait? So let's go ahead and continue the game and create another input. In this input, we're going to ask them a question and say, you've come to a lake. There is an island in the middle of the lake. Type wait to wait for a boat. Type swim to swim across. Cool. So we've actually got the same problem as we had before, namely that this is being interpreted as code rather than as a continuous single string. So do you remember how we fixed this previously? And if you got stuck on this, I recommend having a go at this yourself before I show you the answer. All right, so previously we said we were going to switch it to single quotes instead, so that these double quotes become interpreted as just normal strings. But of course we've got this you've. We could of course change it to you have instead of you've, but if we want to escape the string, we just add a backslash, and now everything is colored in this sort of pinkish color to indicate it's all interpreted as a string, which is exactly what we did previously. Now, in terms of this input, they're going to type wait or they're going to type swim. So let's go ahead and lower the casing for it as well. And then we're going to save it inside a choice. We're going to say choice 2. Now, be really careful and mindful of your indentation, because if you wrote it like this, then it's going to be creating some errors for you, because this choice 2 input line has to run when this choice 1 is equal to left. Otherwise, we're going to get an indentation error. So let's go ahead and indent it here to show that this part is inside this if statement and will only be executed if this is true. And then we get to check our choice 2. So if choice 2 is equal to wait, then it means that the game will continue. But else, so if they typed swim or anything else for that matter, then the game is going to end. So we're going to print and tell them that something terrible happened. You got attacked by an angry trout. Game over. Now we can continue along this path. So we're down to here now. And the final question we're going to ask the user is, which door do they want to choose? So here I'm going to use an input to send them the message that you arrive at the island unharmed. There is a house with 3 doors, 1 red, 1 yellow, 1 blue. Which color do you choose? Now I'm going to save their choice inside a variable called choice3, lowercase the answer that they provided, and finally I'm going to use if, elif, and else to check which one they chose. So if choice 3 is equal to red, elif, choice 3 is equal to yellow, elif, choice 3 is equal to blue. And then I've got a else. So here are 4 possible things that could happen. If they chose red, then I'm going to tell them that it's game over, but it's going to be some sort of creative version of game over. So maybe something like it's a room full of fire, game over. If they chose yellow, on the other hand, well, that's going to be the room where the treasure exists. So I'm going to print you found the treasure, you win. If they chose blue, they also end up with game over, and I have to give them a different reason. Now, if you had decided that if they chose anything but yellow, the way that they're going to game over is the same. Say if you chose red, it's a room full of fire, game over. If you chose blue, it's a room full of fire, game over. Anything else, it's also going to be fire, game over. Well, then you could just use if and else. But if you wanted each choice or each door to have a different outcome for the user, say the red door has fire, the blue door has beasts, and if they chose the wrong door, then they're going to get something like, you chose a door that doesn't exist, game over. So can you see that depending on whether if you want to give the user a different print statement based on their choice, then you would use if, elif, else. But if you actually just wanted to give them the same feedback, which is game over, then you could just use if and else. Now let's run our game and just make sure that it works. So I'm going to go left because I know it continues, and then I'm going to wait for the boat, and that allows me to get to the final condition, and if I choose yellow, I know that I'll win. Now, if you want to change the formatting, because having the input at the end of the sentence doesn't look as good as letting the user type it on a new line, like what we've got here, then you can simply, if you remember, just add the new line, which is \n, at the end of your inputs, like so. So how did you get on with this challenge? And if you didn't manage to do it right, or if you've done it right, go back and try and modify it. See if you can add some more conditions, or see if you can make the game over messages a little bit more interesting than what I've written. See if you can modify it and make it really your own. Have fun with that. And in the next lesson, I've got more exciting things coming up for you. So hopefully you've scheduled some time for tomorrow to complete the next day's lessons. But for now, it's good night from me.